Welcome back. We are continuing along our journey on learning to code using Roblox. In this series here, we're going to finally cover the very powerful, ever useful ModuleScript. I would say probably one of the most important tools that a scripter has in his arsenal. We're going to cover what a ModuleScript is, the various uses for a ModuleScript, and some basic examples of how you might utilize them in a Roblox game. So let's roll the intro and get into it. Alright, so a module script, just like a local script and a regular server script, is a source code container for our Luau code. However, unlike the other two types of scripts, the module script has some requirements for it to run and to run correctly. Mainly, it must return exactly one value. This return value is sort of like a return value from a function, but can only be a single value. So let's create a module real quick and show you what I mean. I'm going to go ahead and create this module in our replicated storage, and you can ignore some of the other things that I have in here. That is for a demo we're going to be going over at the end of this video. So I'm putting it here, of course, because some module scripts like this actually want to be accessible to both the server and client for reasons we'll cover in a bit. Remember, server scripts, aka scripts, right, are run by the server and should usually only go inside of server script service. And local scripts are run by the client, each individual player's system, be it a computer, console, or mobile device, and should typically only exist within one of the starter player folders here, either starter character scripts or starter player scripts. Module scripts don't adhere to being either server or client only by default. So if we want the module to be accessed by both the client and server, it should be created inside of replicated storage like we did. If the module doesn't need to be used by the client at all, then placing it inside of server script service is more ideal. And similarly, if it only needs to be accessed by the client, of course, placing it in one of the starter player folders is likely best. It helps to have your code organized like this to ensure you can easily determine what information is being accessed by which entity and what entity is running each script. So the default code of our newly created module has a local variable at the top named module, and a value assigned to it as a blank or empty table, these curly braces here. At the bottom of the module script, we're giving a return value of this table. So as I said, a module script can only return a single value, so if we were to try to return two values here, let's say also just the number 10, right, it doesn't matter what data type it is, we would get an error when accessing the module. So to demonstrate this, I'll show you how we get the returned value from the module script. In order to do so, I'm going to go ahead and create a server-side script. Put this in the server script service, of course. We'll just do a script here. I'm not going to worry about properly naming things right now. Again, when we get to the demonstration at the end, you'll see more accurate ways of doing things. So with this, we're going to go ahead and get a reference to our replicated storage first. We'll do local replicated. Make sure I'm spelling that right. Storage, and this is going to be equal to game get service and our replicated storage. All right, so now we have that. We can go ahead and grab our module script, which is just named module script. So in this case, I'm just going to call this local module. You'll notice that just like with the service, I am using a capital letter here. This is called Pascal case, right, where each word has a capital letter at the beginning there. Unlike normal variables where you use camel case, right, which uses a lowercase letter in the front there. So anything as far as services or modules or even the names of files themselves, you want to use Pascal case. And I believe those are the only three things that you'd want to do that on. We will be going over the Roblox style guide in a video here very shortly. Once we actually finish covering this, we'll have everything that they're pretty much talking about, so we can deep dive into that. Otherwise, let's go ahead and get our module, right? So normally we would say replicated storage.module script, which is going to get a reference to the script. But that's the problem. It's only going to get a reference to the actual script itself. How do we get access to the return value? Well, for that, we need to actually get our require function And we'll go ahead and make sure we've got this inside the parentheses. We're passing our module script as the argument for the require function. And you can see when I hover over this, this returns the value. Oh, let me try that again. There we are, returns, okay. It's gonna give me problems here. There we are, returns the value that was returned by the given module script running it if it has not been run yet. So that's something to keep in mind as well, and we'll talk about that here in a second. So if I go ahead and run this, it's a server script, so we don't have to play the game, so I'm just gonna click run. You'll see module code did not return exactly one value, right? And we can click on that and we can even see it's coming from here. Now notice this doesn't take us to the module to say where that is. Fortunately, we can see where that module script is. So we can come in here and go, oh, okay, I see it's this. Now, of course, if I clear that and I hit run, you'll see we don't get any issues. Let's do a quick dive into tables for the purposes of clarity here. So there's going to be a much more expanded section about tables in a video, and a more advanced video in the future, but for now we'll kind of get this here. So we'll go over how tables are defined, etc. We're going to go ahead and ignore everything else that we have in here right now, and we'll just start this here. So a table, basically, we'll say local table, TBL for short here. We create that by using these curly braces, so this is now an empty table, right? And this is different from parentheses, obviously, and it looks similar to parentheses. For example, if we put parentheses in here, it's kind of hard to differentiate between the two, right? You know, if we had a value in here or whatever, it doesn't really matter. So one thing that you always want to try and do is actually have a space after and before your curly braces. And if you are using something like VS Code, which I have a video on using Rojo on that, you can get a styler, basically, that whenever the file updates or saves, it will automatically enter that sort of syntax for you. But otherwise, so we can hold values of any type here, right? So I can say like 23, I can say hello as a string, right? I can say negative 256.9, which is technically a float. They're all numbers in Lua though. And I can even say true, which is a Boolean value, right? So this is an array of mixed data types here. Another thing to note with tables, when you're doing these, it's a good idea to include a trailing comma at the end. And this basically allows you to move things around if you need to, but more so it will actually make it so you can edit things a little bit easier if you just need to add something. You don't have to worry about, oh, I didn't add that comma there. It makes more sense if you actually break the table up a little more like this, though. That almost would have been easier just to type this. But you can see now, so this is another way you can write this, and this works the same, but let's say I want this true value to be somewhere else. I can hold Alt on my keyboard and press up, or up or down on my arrow keys. No matter which line I have selected, I can actually move these around. And now you can see if I just decided I wanted to move these around for whatever reason, with them all having these commas afterwards, then I can do that without any issues, without breaking it at all, right? All right, so indexing tables, right, is how we get the value at the specific indexes. I'm gonna go ahead and we'll go back to when this is just lined up, just to make it a little easier. So the first value in Lua is going to be index 1. In a lot of other programming languages, they start counting at 0, so it's kind of nice that the creators of Lua in Brazil there, they decided, no, we're gonna count from 1 like normal human beings, although I still get used to counting from 0 most of the time. So this would be index 1, this would be index 2, index 3, and index 4, right? So the way that we can access that is I could say print table, and then we use square brackets, right? So these are basically share the same key as our curly brackets. And we can say index 1, and if we print that, that's going to print the number 23, right? And if I go ahead and print 4, that's going to print true for us. Okay. Now what happens if I say something that is not in our table, right? We don't have an index 42. Well, we get nil. So it's technically still going to give us a value. It's not going to error out. That value just happens to be, well, specifically nothing, nil, right? So this is what's called an array, where we're just using basically an implied numbered index, right? Where you could kind of think of these as being, so now I will actually go ahead and break these out into their own line because it's going to be a little easier to show this. Typically, you know, depending on how many values you have in your table, it's going to be better to either do it this way or the other way. So for example, if I want to, we'll go get rid of this print statement here. If I wanted to kind of show how this really looked, right, this would be basically like this, right? And you see we'll get some errors because not all of these are going to be the same. And you'll even see that when we hover over this, it's saying, oh, index 1 is a duplicate, right? Because if I'll get into that in a second, actually. So we'll set 3, and then when we do 4, the error should go up for us here. There we go. So this is essentially the same thing that we had just a moment ago, except now this is actually what's considered a dictionary, where we have a key and a value assigned to it. And then the difference of this is that we can call the key, and it doesn't matter what order these are in anymore, right? Because these don't technically have an order once they are key value pairs, once they're a dictionary. They only have an order if you don't actually include the key, because then it just indexes them one by one. And that's the reason we were actually getting the error there, or the warning, I should say, is because if we get rid of these, for example, what's happening here is we now have a mixed table of key value pairs and indexed values. And what the problem is that it's noticing, wait, well, this is index 1, but it will automatically find the first non-keyed value in the table and apply index 1 to it. And then this would be index 2, and that's why these are both yellow here and why it's saying that they're duplicate keys basically in this table. So highly, highly, highly suggest not to ever mix key value pairs or basically dictionaries and arrays together, or lists, however you want to say it. All right, so another cool way we can access this. So let's go ahead and do our for loop to access these. So let's say for I, right, this is the index, in, and we can say our table do, right? So what this is going to do, index value in our table. So again, the index isn't showing up here, but it is implied, right? We can go ahead and print the index and the value. And when we run this, we'll see that we get everything printed out. Index 1 is 23, index 2 is hello, etc. So these are just variables, and we typically want to name them a little better, right? So we know what they are. Now, obviously, if you are just using an array like this, using I here for index is perfectly fine. It's perfectly common. If you happen to nest another for loop in there and you need to do something like that, another common convention is going to the next letter and saying for J, for the second index group there. But in our case, we would say for index value, right, in table. And this is going to be basically the same thing, except obviously we need to change these up. You'll also notice I'm just saying in table, right? And it's just going to loop through the table and do that for us. However, if you absolutely need to know what kind of table it is, either an index table or a dictionary, then you can use the Lua style. And I say that because this is actually something that the developers of Roblox made for us, is a little shortcut where this will automatically infer what kind of table it is, and it, whether it be an array or a dictionary, and will automatically apply one of these things to it. So in parentheses, we would say I pairs because this is an index pair situation, right? However, if I have, we'll say first equals that, and second equals that, third equals that. And again, the order of these don't actually matter. I can call this next, right? It doesn't really matter. Probably not gonna wanna, when it's blue like that, it's a keyword. It's not really gonna matter here, but another thing you can do if you are using essentially strings for your index, not only put them in the quotations, but then also surround them with square brackets, because again, that's how you index something, right? So that's just kind of showing you. This is still exactly the same thing as the others above it there. So now if we do this, we would actually just want this to be in pairs, right? Because it's key value pairs, not index pairs. All right, so again, if we run this, we get the same thing, but now we get our different stuff here, and you can see that this is out of order. And again, dictionaries do not have a specified order how they're going to actually be looped through. So you want to make sure that you're doing something with that, right? Now, another thing to note is, let's say we don't actually want to use the index in our in whatever block of code we're putting in our for loop in this case. Then it's kind of a good idea in common convention. You can do this for either of these values that you're not using, both if you're not using either for whatever reason. You basically just replace it with an underscore. And that way it just kind of shows that we're not actually using this value. It's easy to see that when you're looking at it. Also, again, if you're using an external editor, the editor's not going to yell at you that you have an unused variable that you are creating. So showing that it's an underscore works there. You can also put an underscore in front of the word, and it will also technically work as not giving you an error in that external editor. But for now, otherwise, this basically works the same way, right? Now you just get the values. All right, so that is basics of table stuff in Roblox there. So like I said, we'll dive much deeper into tables in an upcoming more advanced video. For now, we can discuss one of the purposes of ModuleScripts, one of the main purposes anyways. If you recall from our functions episode, which you can find on the channel in the same playlist as this, we want to follow the dry principle. Don't repeat yourself, right? And ModuleScripts are essential when adhering to this. So you can write a function once in a ModuleScript and then use that function anywhere that this ModuleScript is then required. So let's show this off by adding a simple add 5 function here. So I'm going to say add 5, and we'll spell it out. Add 5 equals, and this will be a function. We're going to take in a number, and then we are going to go ahead and just simply return the number plus 5. All right, so there's a couple ways we can define the function, and this is just one of the ways. I definitely don't necessarily recommend doing this. This is a different way for defining a function than we'd really like to do. But we're essentially creating a key in our table called add 5, and its value is the function itself. So of course, we're returning a value, so we need to make sure that anything we want to actually get from there is going to be stored in a value. We'll just say result here, and we can do module. And now to access this function, we're going to use dot notation, and you'll see that add 5 pops up there. It even tells us that it takes a number. Well, it tells us what we want there. It's giving us any type, and it's returning any type. That's because we didn't dictate what types or assert what types that we're putting on that. That is also something we'll go over, I believe, in the next video. So we'll go ahead and select add 5, and now we can put in a number in there, right? And if we go ahead and print the result, and we run this, you'll see we have 15. And not only, is it just using a function, so I can reuse this anytime I want, as many places as I want, right? So we can just go ahead and print this directly, for example, where that came from. That, and then we can go ahead and let's copy this down a few times, and we can say like -4. I think we've done something similar to this. 42 and 25.3 on it. That is not a -4. Don't have a result anymore. Of course, we run that. The difference being, though, is that we can also call this module script in anywhere else, so we can call it from a local script, for example. And I'm actually, just for the sake of time, going to go ahead and just copy this because it's going to be exactly the same. In fact, all of this is exactly the same. I'll tell you what, I'll just grab these two. And we'll put that there, and when we run this, you can see we have that. Why didn't we get the local? Well, that's because we didn't wait for child, right? And we'll do ModuleScripts. And now when we run this, it should work for us. It's not. Why is it not? Oh, I'm a fool, because I'm hitting run instead of play. Obviously, the local scripts don't work if they're not playing. So there you can see these are coming from the client here. Right, so what is actually happening is the server is requiring the module, and it's essentially making a copy of this. It's also going to run any code that's in here. So if we had a local function that's running inside the module, it would run that code on the server, right? Which is why this is coming from the server. And then the local script is going to require it, and it's going to do the same thing. Not only is it going to basically kind of make a copy of it for itself, or be able to access it for itself, but it's going to run any code that's within the module on the client, and every client in that case would run the same code, but it would run it on its individual client. So I hope that makes sense. We'll kind of move on though and go over that. All right, so I mentioned that this is not really a good way to do this. Instead, we're gonna go ahead and show you the better way to do adding basically a function to our table here. You can add things to the table by also just saying the table's name, right, module, dot notation, and then you can say like num, right, and then this would be 10 or whatever. So this is the same as doing num equals 10 in our table here. Right, so key value pair, we've just created a key, which is num, in our module table, and we've assigned it the value of 10. I hope that makes sense. In this case, we are going to do a function, right? So we're going to just say function, and you'll notice I'm not using the local keyword here. The local keyword will strictly keep anything that has it inside of the script that it is, in the scope of the script that it is in. Whereas if we do not use the local keyword, we can actually utilize it outside of the script. And since we are trying to utilize the function for anything that is returning the value of module, then we want to make sure we're not including the local keywords. We'll say module, and we'll do that add 5 there. And again, we're going to say num. And we're just going to do return num plus 5. And you'll see that this still works exactly the same. So no issues there. All right, so having functions within required modules like this means that if you need to change anything about that function itself, it doesn't matter how many different places you're calling or using the function, you only need to make the change in one single place, right? One single script. Therefore, you're not repeating yourself. You should define functions you're going to use in multiple places, or even whole groups of functions inside of module scripts to keep your code organized. I would recommend that you try to keep your modules specific to doing one thing, or, you know, if you don't want to just have this full of a bunch of random functions, you ideally would want to have, you know, like we can call this, let's call it, I don't know, we can call it mathematics, I guess, if I can spell it. And then do this, right? And then we'll go ahead and rename this to mathematics. Of course, we'll also need to change this. We'll change these as well, just to be clear about what we're doing. So with mathematics right now, you know, if we wanted to add a second function for example, and say that this is just, I don't know, add nums. And we take in num1 and num2, And then we're gonna return num1 plus num2, right? So these are obviously two similar functions, and they are related to each other in the fact that they're both like mathematical functions, right? They're both doing some sort of math. So when you call this, you know exactly what this is, as opposed to having, you know, something that greets the player as well inside of a mathematics table or inside of just some random table that also includes other things. So again, try to stay organized, all the good stuff. So it's important to note where the return value of a module script is being run from by where the module is being required from, right? So in our server script, obviously, this is coming from the server, as I mentioned. The function itself is being run from the server. The actual stuff in here, so if I did a local function, again, that's going to be local and actually run in this. And we just did, I don't know, we'll say return 10, which is just kind of a weird function. I'm just doing some basic simple stuff here, and we will return the number 10, right? So if I wanted to change this to add 10, or better yet, we'll just make a whole new function here. We'll go place it here, and we're going to do add 10. And instead of num, we're going to do return 10, like that. So what will happen is we're going to want to actually not do it that way. We'll do this. We'll say local value is return 10. And now we can just put in value here. And what'll happen is when the server calls this, right? If I print value, this is before any of the functions are being called. In fact, I can tell this not to call them at all. Same thing on the local script. So if we play now, you'll see that the server has performed that internal function, that local function on the mathematics script to give us the value of 10, and then the client also did the same thing on its own. So that is how that is going to work. Basically, whatever is requiring it, whether it be the server or a client, is going to do exactly what it said in here, where it said that the script will be run if it has not been run yet. That's another thing to keep in mind as well. If we had multiple scripts or local scripts, all requiring the same module, it's only going to run the one time on that server or client, and then it won't continue to run afterwards. So of course, module scripts need to be required to run at all. So even if we have this code in here to actually do something in the module script, if nothing is requiring it, then we're never going to get any values down here whatsoever. It's never going to actually perform that. The module script has done nothing. Nothing's required it to do that. All right, so server script should typically run before clients, of course. So a require to the module script from both a server and local script results in the server calling it before the client, as you saw there. It's also good to know that the module script won't yield, meaning it's not going to pause or halt running its code unless there's actually a task.wait or similar call in the module itself. So more on the task library in a future episode as well when we go over some more advanced stuff. All right, so make sure to subscribe, be notified when that one goes live. All right, a quick aside here. If the module script is named main module, like so, and you upload this to Roblox as a, off screen here, there's a save to Roblox option on the menu there. And if you upload this as a model to your account, you can actually require it using the model's asset ID and not even need the module script to actually exist in the Explorer here. So let me go ahead and do this real quick. We'll go ahead and just save that. And I'm going to go ahead and copy its asset ID here, which you can of course get from your toolbox as well. And now what I'm going to do is I'm going to go ahead and delete this. We are going to go ahead and uncomment these. These are going to run again. Now, of course, it's not going to find them there, But instead of doing replicated storage.mathematics, we can actually just use the asset ID itself. And when we play this, you'll see that it is doing the same things. Oh, right. So this only, I forgot to mention, this should only work on the server, right? So we required it on the server, which goes in the call stack there. And then the server's doing the different things that it needs to do. You can see that Studio itself ran the function. Obviously, if you're in a game, that is going to be the server that's running the internal function on the module, but it's doing it on the back end so that you don't really see that happening. So there's little things about, little oddities about doing it. Again, you can't do it from a local script that way. So those are just some things to kind of keep in mind when you're doing that. Nice thing is that these are basically private modules on your Roblox account. That's pretty cool. You can possibly avoid some exploitation as well, especially, if there's no module for them to try to tap into and do anything within replicated storage. They might not even know it exists there, right? And they'll be like, I don't know how to get into that and do anything. So that's just something kind of cool you can do there. All right, so what else can we do with ModuleScripts? Let's go ahead and bring that back. We're going to this. And we'll go ahead and comment those out again. So another thing we could do, change this to player data. So rather than just storing functions, we can also store just values as well, right? So if I open this up, and we are going to call this, we want to make sure whatever you're returning is the name of the file, or the other way around in this case. That way it is also adhering to the style guide. Just makes it clear exactly what it's doing. All right, so since we're returning a table, we can simply just use key value pairs or a dictionary within the table to store any values we want. This makes a module really great for building databases, essentially. So for example here, I can do this. We'll copy and paste that in there from another script that I have. So here you can see we are also nesting a table within a table, right, a couple times. So we have a currency key that is being assigned a table, and that table has two keys in it, coins and gems, which are each 0 here. We also then have an inventory key, which stores a table, and that table has two values. It has a sword value and a shield value. Each of those are tables that contain 3 values, price, damage, and equipped for the sword, price, armor, and equipped for the shield. All right, so pretty straightforward. So we'd want to perform, or we could then perform some function when a player joins the game, and it would set their save data, right, to like this default template that we just made. If they already have data saved for them because it's not their first time joining the game, then we would only want to write any new values within the data template that didn't already exist in their previous save data. So let's say that you perform an update at some point and you decided that you're also going to include a health bonus, right, in here, or better yet, a whole new value for health, right, and set that to 100. And again, you want that trailing comma, because then you can move things around. Like if I want this to be alphabetical order, for example, which I do, I can move that up there like that. Again, that's holding Alt and using my arrow keys. So we've performed an update, right? The players have already been in the game. They didn't have this health value in their data when they join the game. Now we would update so that only the health data, only values that didn't already exist would basically be written to their data at that point. So data stores and player data is a more advanced topic. I promise we will cover that in the future for those who are interested. We can access each item in the player data table just like we access any value within a table. So either with dot notation or using square brackets. Right, so we can do that from here, for example, and we'll do player data. And also commented there. I'll just copy these because I'm lazy. Most of this, and we'll just say player data, and now I can hit dot here and you can see that I can access inventory, which it even shows you the stuff that's in there. the health, which is a number, or a currency, which has coins and gems. So let's say we want to know how many coins that the player has, and we can print that, and it's going to give us 0, of course. All right. So module scripts are a great way to organize your code, allow for easy, reusable code. Basically, you can use that throughout your projects, right? It can be located in a single, easy-to-access place. If you need to add or update things, it's right there for you. A good rule of thumb is that normal scripts, right, whether they're local scripts or a regular script, should be used for standalone elements or features of a game, while module scripts are used for storing code that can be reused by multiple independent scripts. It's also a good idea, again, if you have something that's going to kind of have multiple functionality built into it that you're going to use even just one other script, you can use it to abstract away all that information into a module and do that way as well. So I also want to point out right now that we don't always have to structure our module script like this. If we're simply storing a single value within our script, for example, here we only have this table. We're not doing any functions, we're not doing anything else like that. We can actually just return the table, because again, we are still just returning a single value, and this will work exactly the same as it did before. In fact, I can show you, still runs, gets 0. All right, so now that we've covered server scripts, or just scripts as they're named, and we'll go ahead and clear these. We'll go ahead and do our demonstration I was going to mention here. We've covered server scripts, we've covered local scripts, and now we've covered module scripts. We can start to think about how communication is handled between the server and a player's client machine. So data that the server needs to know about but shouldn't be able to be accessed by the client can use a module script located in replicated storage that handles the communication between server and client. So again, a lot of this will come to light when we go over data stores and saving and loading player data. So let's end by briefly discussing the MVC design pattern. MVC stands for Model View Controller, which represents the 3 interconnected components you might think about when determining what type of script to use for a feature and where to place said script. So this is obviously not something that you have to follow every time. This is just a great exercise in figuring out a good way to organize things. So the model is essentially the server, and it manages data, logic, and rules. Right, so in a game, this could include game states, player data, other core functionality that doesn't need anything to do with the client directly. And you might think, well, doesn't player data have to do with the player? Yes, technically, but you don't want the player to have access to that, right? You just want to basically show the player their data as opposed to letting them access it directly. And that's where the view is, right? So view is basically your client or local scripts in some cases, right? It's responsible for presenting information to the user, either in terms of user interface, the GUI elements like menus, health bars, currency amounts, etc. Right? This could also be specific changes to the client's functionality, like the ability to sprint, for example, even though that makes the view name a little messy when applied to this thought process. The controller is then going to be your communication between the server and the client. These will typically be your module scripts in replicated storage, but could be as simple as an event as well, right? A remote event, a remote function, that sort of thing. So here's an example, kind of a quick overview of this architectural design that could separate these. So imagine you're building a farming game, right, where players can plant, grow, and harvest crops. So we could basically, on the model, create a crop class, right? And that crop class is going to have properties and methods that are shared between different crops that you create, like corn, onion, potatoes here, right? So each of these crops are going to have a growth time, harvested time, or sorry, a growth time, whether or not they've been harvested, and whether or not they've been watered. You should also have methods like grow, which is basically a function that you call on the crop itself. Water, again, another function that you call on that, right? So this is going to simulate for the crop to grow. This is going to water the crop, and then give rewards would be another one to basically reward the player when the crop is harvested, right? Give them whatever they're given. The view, we're going to skip over the controller here. The view is basically going to handle again, like your GUI and the actual interaction coming from the client themselves. So for example, if you have a model of a crop on your game world, and there's a button, a GUI button there to water that selected crop, it's going to basically send an event over to our controller, which again is handling the communication there. And the controller is going to call its function there, or the view essentially would call the function water crop and pass in whichever crop that it has selected. The controller is going to say, okay, well, let me go ahead and call the water crop function, sending that event over to the server. The server is going to say, oh, okay, I'm watering this. So first thing I want to do is mark the crop as watered. And then we're going to go ahead and send back and say, okay, we also need to start the growing of the crop. And then both of those would then send back to the controller saying, hey, the crop has been watered and is starting to grow, which then the controller can send back to the client to say, you know, update the GUI and or the cropped model, like put a water dripping particle effect or something on the crop model or whatever to show that the crop has been watered, and also to start the grow timer GUI on there as well if you want to do that. And of course, that would also be on the crop itself is going to have its own grow timer, and that's where you would basically pull the time from. I recommend in that case using UTC, not necessarily server time or client server time, OS time, just because those can get out of sync. You could, if you're handling all your times on the server anyways, you could definitely do server time. Nice thing about that is it doesn't necessarily allow the client to make adjustments to their own time to do things. The problem though is that they could do technically server hopping, and you might get a server with a different time on it, and it could affect things when it goes to sync things up. So using UTC for that is ideally better. That's kind of an aside though, and really has nothing to do with what I'm talking about. So back to our game here. So we can go ahead and show you a real use case scenario in here. So on the client, if I go ahead and hit play, we have a button here. It's been here the whole time, the open button. If I click this, this is going to open an item shop UI. All right, so each of these items is available for purchase. You can see when I hover over these, it also updates which item is on here and how many of them I own. It also has how many coins I have. I'll show you how all this works here in a second. And when we see we have 500 coins, we could buy one bag, we could buy one shield and 2 swords, or we could buy 5 swords, or different combinations of things therein. So if I buy a bag and spend all my money in one place, you'll see we get a message to purchase bag. You'll see our coins updated to show 0, and you'll even see that our bags owned has gone to 1, right? And that still updates when we hover over as well. Now if I try to purchase something else, another bag, a shield, or even a cheap sword, we don't have any coins, so it's going to tell us that there's not enough coins. Now the client is handling none of that actual checking. It's not saying, do I have enough coins? It's asking the server, excuse me, sir, do I have enough coins to purchase this sword? The server's gonna go, oh, sword's 100 coins. You have 0 coins, so no, you have not enough coins. All right, so it's not updating that there. We can go ahead and stop and play again so I can show some other options here. So for example, we can purchase this, and that still works. If we go to purchase a bag or even another shield, we don't have enough, but we can purchase a couple swords, and you can see this does update properly with the 2 there. And this is all gonna work. Even if we close and reopen this, it's all still the same. So that's all good. So let's show how this works in the background. So we'll start with our replicated storage stuff here. So we have a bunch of events. We've got a few different remote functions, and we do have some remote events, and then we have a couple bindable events as well. So those, of course, if you look back at my events video, which was just prior to this one in this series, you'll see that bindable events, of course, are on the same side of the server-client boundary, so either server-to-server or client-to-client. And then remote events are on the other side, so they'll reach out and ask the other way. And you can see if they're remote or bindable, but whether or not they have a little computer icon or server icon there. So in here, we have a couple things. We have a player data template, which is exactly like what I just showed off a little earlier. In our case, we've only got coins that we're storing here for the player's default template. and we're not giving them anything in this case. This is literally just actually exporting the type of the player data. So don't worry about that for now. We'll get into that when we do types in the next video. But we do have our controller, right? I'm going to pull up actually from the start here in our GUI scripts, our item store. This is a local script. This is going from the client side. So we're getting our different services. A lot of this is just for the GUI itself, so don't worry about a lot of that. You can see here we are requiring our controller script. That's the only thing we're requiring. If we look over in our server script service, we actually have a few other module scripts in the server itself, and obviously these are not accessible to the client. So we're getting a reference to our events, so we can use those as well. This is just getting a reference to the player itself and all the different buttons and GUI elements we have. And then we have our different data values. And again, this is all the GUI stuff. So update owned items from how many we have of the items, right? This is a function that we made here, and we're getting the player's data. We're doing that by sending an event get data from the controller. And this is an actual method or function being called on the controller script. So we can come in here and see where that is. You can see here get data is to update the player data from the server. So this is essentially the client requesting its data from the server, right? And this is going to return a player data template, basically, our player data. So what this does is it first checks if data is loaded, because when the player starts up and first requires this script, we're doing a little trickery here to try and load the player's data and make sure that we're getting the player's data actually saved on this script first, because if it already has the most up-to-date stuff or needs to be accessed right away, it's good to have that. It also just lets us know that that was successful and we're not going to get any errors. A lot of this stuff I'm going to go over doesn't have as much robustness as I would normally put into my code to handle errors and things like that. So keep that in mind. This is a very simple example, despite how complex it looks. All right, so what we're doing though with this get data function is we're simply returning a remote function here, invoke server, right? The get data remote function. You'll notice that this is a little different. All right, we have our get data here versus just calling this get data function off the controller itself. Not a remote function or anything. This is a remote function. So let's go ahead and open up our purchase manager on our server. And this is basically what's in charge of handling purchases, right? So the first thing it does is creates a table of profiles. And in our data manager, whenever the player is loaded up, right, whenever they're added, we are essentially creating an index using our player's user ID in our profiles table, which is this table here. And then we are setting default player data, which is that player data template, right? So we're just setting their data to whatever the default player data is. So that's how we get that. So now when we try to get the player's data, we are basically going to use this in a couple different places, as you can see down here. So this is just doing a little bit of error handling and is essentially just returning whatever their profile is in that table. So all of their data there. So what's happening down here in our events, we have this get data function, the remote function, right? So when it's invoked, we're calling the get data function within here, which is doing this. And all we're doing is trying to get the player's profile, which we are returning back to our controller because it is invoking here, right? Which is returning what is being asked from here. So now player data is going to equal whatever the player's actual data is without the player directly having any access to that whatsoever. And then basically if the player's data has the key of whatever item we are currently updating, then it will update to show how many items it does have that. Otherwise it's going to show 0 if that doesn't exist. So next thing we're doing, this is to update messages, don't worry about that. Purchase result, right? So what we can do here is we'll just skim down to where the image buttons are. So for each button that we click on, this is for each of the items that are in there. Whenever we click on the button, we are requesting to purchase, right? And we are firing, again, this is just using Fire, not Fire client, Fire server, or anything. So this is a bindable event. We are requesting purchase through our controller. So we come in here and you can see we have the request purchase event where we were passing the actual item, just the name of the item is all we need. And then we are then firing an event to the server because remember our controller that's getting this is being activated and requested on the client side. So this exists on the client. So we do need to cross that server boundary and get the info. So we're just requesting the purchase. This is one-way communication. We're just sending the item name. So when we go into our purchase manager and we see we have our purchase request, we are connecting our function purchase, which is up here. This is getting the player that sent the request and the item name that we sent across there. We're trying to get the player's profile. If for whatever reason that fails to get the profile, we're actually sending a false result back to the client so that they know that there was an error and they did not successfully purchase that regardless. And then we are getting the items price from our items table. So we haven't gone over that, but that is yet another module script we're requiring that lives on the server. And this is where our actual item data exists, right? So we've got our sword, our shield, and our bag, and the different prices that they have. So this is really useful, obviously, because again, the client has no access to this, so they can't make this 0 and just purchase bags for free, right? Instead, it's all handled again on the server. So we are getting the actual items price through that, not from the client, because we don't want to depend on the client to be truthful about, how much the item costs. We want to actually see how much the item costs. And then we are checking if their amount of coins is greater than or equal to the amount of the item's price. So in other words, can they afford the item? And then if they already had, so if they do, right, if they have enough, we're checking to see if they already own one of those items, if that key already exists. If it does, then we are just adding 1 to that. If it doesn't, then we are creating that key and setting it to 1. And then we are performing another function from within here called adjust coins, which is essentially down here, getting the player's profile, getting their coin amount, and adjusting it by the amount of coins that we had there. In our case, it was the, here it is. It is the negative of the item's price, right? We're removing the item's price from their coins. And then we send our confirm purchase remote event back to the client to basically say, to that client specifically, yes, true. So this was successful. The item name, we're using that just in case. We're also going ahead and sending how many of that item they own. And we're sending how many coins that they have on their profile. If they obviously don't have the amount to succeed there, then we're just sending false, it did not succeed. So back in our controller, because we were sending the confirm purchase, right? Back in our controller, we're getting this confirm purchase event back, and we have the item purchase result, which is all of that we sent. And you'll notice that it is all of that there. This is a function that we're calling here, and you can see that we have our success boolean. These question marks means that these are optional, because remember, you could just get a true or false value. So you could just get false here and none of this other stuff. So we want to make sure that if that stuff isn't there, then it doesn't matter. So we're immediately checking if success. If we were successfully able to purchase it, we are then firing the bindable event received purchase. Otherwise, we are just sending, that it was false. So again, back into our item store here, when we have received purchase, we're getting the purchase result function to go off, which again takes in all the same stuff. But in this case, now we are updating, right? If the purchase was not successful, we're updating our message that you saw at the bottom of the screen there to say not enough coins. When you update the message, it also is doing the tween service to fade in and out and stuff. And then if they did purchase it, then we are doing the same message, but we're doing purchased, the actual item name itself there. We're also updating the player's coins on their end, right? So the GUI side is getting updated to however many coins they actually have. And we're updating on the client side again how many of the item that they own, so that that's updated on the GUI and it's all updated there. All right, and then I just have my open close buttons. So that is a very long-winded way of showing how all this works. But you can see that, everything is working as intended here. That's using that MVC, that model view model view controller pattern, design pattern. That again, you don't have to use it specifically like that. It's just a good way to kind of have the mindset of where to put things, how to organize things. So again, this may seem somewhat convoluted to do a thing like this. It not only keeps things safely separated into that need-to-know separation where everything is only working on what it can and not an all-in-one access, which is more easily able to be exploited. It also means we have that code organized, right? So this makes adding additional features and functionality much more simple and straightforward as the complexity of your game and your systems increase. So this was certainly quite a lot to take in, and I used some things in that example that we may not have really covered just yet, but we're nearly complete with our basic episodes. Again, I got one more for you. Make sure to subscribe if you haven't already. Hit the notify bell to be aware when new episodes do go live. I hope this lesson really helped some of you out there. Let me know in the comments if it did. And with that being said, I will see you next time.